Let's dive into the world of data models and understand their significance. Normalization is essential for organizing tables and columns in a relational database to reduce redundancy and improve data integrity. It helps eliminate redundant data, minimize errors, and simplify queries. Data models typically consist of fact tables, which contain numerical values, and dimension tables, which contain descriptive attributes used for filtering or grouping. Primary keys uniquely identify each row in a table, while foreign keys relate to primary keys in dimension tables, ensuring data integrity. A star schema is a simple data model with a central fact table surrounded by dimension tables. A snowflake schema is a more complex version with additional layers of dimension tables. In data models, you can set relationships to active or inactive to manage how data is connected. Only one active relationship can exist between tables at a time. Managing active and inactive relationships is crucial for accurate data representation. You can edit these relationships in the Properties or Relationship dialog box. Cardinality defines the uniqueness of values in a column. Ideally, relationships should follow a one-to-many cardinality for accurate data modeling. A one-to-one relationship connects tables using a unique product_id, simplifying the model by merging tables into a single, valid dimension table. A many-to-many relationship can cause ambiguity, as multiple instances of product_id exist in both tables. This can lead to confusion in data representation. Connecting multiple fact tables through shared dimension tables allows for comprehensive data analysis, even without a primary, foreign key relationship. Visualizing data helps in understanding trends and patterns. Here, we see total orders and returns by product style and date. Further visualizations show total orders and returns by continent and education level, providing deeper insights into the data. Filter context and flow are crucial in data models. Filters always flow downstream, affecting related tables in the direction of the relationship. To filter both sales and returns data by territory, use the territory key from the lookup table. This ensures accurate filtering across both fact tables. Bidirectional filters allow filter context to flow in either direction, providing more flexibility in data analysis. With bidirectional filters, we can see correct values using the territory key from either table, enhancing data accuracy. Enabling two-way cross-filtering between returns and territory tables can reveal missing data, ensuring comprehensive data analysis. Use two-way filters carefully to avoid ambiguity. One-to-many cardinality is preferred for simpler and more accurate data models. Thank you for joining this session on data models. We hope you found it informative and useful for your data analysis needs. DAX formulas are a lot like Excel formulas. DAX even has many of the same functions as Excel, such as date, sum, and left. But the DAX functions are meant to work with relational data like we have in Power BI Desktop. Let's recap the difference between calculated columns and measures. Calculated columns are values added to each row of a table and stored in the model, primarily used for filtering data. Measures, on the other hand, are calculated based on filters in the report and are used for aggregating values in report visuals. DAX operators are essential for creating expressions. They include arithmetic operators like addition and multiplication, comparison operators like equal to and greater than, and text, logical operators for combining and evaluating conditions. DAX functions are categorized into various types such as math and stats, logical, text, filter, table, date and time, and relationship functions. Each category serves a specific purpose and helps in manipulating data effectively. Basic math and stats functions in DAX include sum, average, max, min, and divide. These functions help in performing essential calculations on your data columns. The sum function in DAX is used to evaluate the sum of a column. For example, you can calculate the total quantity sold, quantity returned, or average retail price using the sum and average functions. The count function in DAX helps in counting the number of rows that contain a number. You can use it to count total returns, total orders, and total customers. Additionally, you can calculate the return rate using the divide function. Logical functions in DAX include if, IFERROR, switch, and OR. These functions help in evaluating conditions and returning specific results based on those conditions. If statements in DAX are used to evaluate a condition and return one value if the condition is true and another value if it is false. For example, you can determine if a parent exists in the customer lookup table. The switch function in DAX evaluates an expression against a list of values and returns the result corresponding to the first matching value. For instance, you can use it to assign month numbers to month names. Switch can also be used for more complex conditions. For example, you can categorize product prices into high, mid-range, and low based on their values. Combining switch and if functions allows for more detailed categorization. For instance, you can determine customer priority and income level based on multiple conditions. The switch function can also categorize education levels. You can map different education levels to specific categories like high school, undergrad, and graduate. Text functions in DAX include len, concatenate, upper, lower, left, right, mid, substitute, and search. These functions help in manipulating text strings within your data. Text functions can be used to create full names, abbreviate month names, and categorize SKUs. For example, you can concatenate first and last names or convert month names to uppercase. Date and time functions in DAX include today, now, day, month, year, hour, minute, second, weekday, weeknum, AO month, and date diff. These functions help in performing date and time calculations. Date functions can determine the day of the week, identify weekends, and categorize dates. For example, you can use weekday to find out if a date falls on a weekend. For your assignment, use the year function to extract the birth year from the customer birth date. This will help in analyzing customer age groups. The related function returns related values in each row of a table based on relationships with other tables. It's similar to VLOOKUP in Excel but works with relational data in Power BI. You can use the related function to find related values like retail price and calculate revenue by multiplying retail price with order quantity. The calculate function evaluates an expression in a context modified by filters. It allows you to override existing report filters and force new filter contexts. In this example, the calculate function modifies the filter context, flows downstream to related tables, and evaluates the measure against the filtered table. Here, calculate is used to determine bulk orders and weekend orders by applying specific conditions to the data. DAX measure totals can be tricky as they don't simply add up visible values. Understanding how they are calculated is crucial for accurate reporting. These examples show how to use calculate to find total returns, sales, and return rates for bikes by applying category-specific filters. The all function is commonly used with calculate to remove filters and calculate totals or percentages of all orders. Here, we define measures for total returns, total revenue, total cost, and total profit using calculate and other DAX functions. Year-to-date, YTD, is used for tracking progress over a year, while HASONEVALUE checks for a single distinct value in a column. These measures help set and evaluate revenue and profit targets by comparing current values with previous month values. We calculate previous month revenue, profit, returns, and orders using the DATEADD function to shift the date context. These measures calculate the overall average retail price, high-ticket orders, and bulk orders by applying specific filters. Here, we adjust revenue and profit calculations by incorporating price adjustments and calculating average retail prices. These measures calculate 90-day and 10-day rolling profit and revenue to track performance over time. ETL processes involve extracting, transforming, and loading data from various sources into data warehouses for analysis. There are several popular ETL tools available, each with unique features and capabilities for data integration and management. Analytics dashboards consolidate data from multiple sources, track key metrics, and facilitate data-driven decision-making. This step involves selecting the objects on the page to include in the analytics dashboard. This e-commerce dashboard example shows total revenue, profit, customers, orders, and returns, providing a comprehensive view of business performance.